Students, can you see the screen? I will online. Anushka, Lamula, Rana, Anushka, Rana.
Yes, sir.
I will. Excuse me. Okay, give me a minute. Is Naomi online? Naomi, Yusra, Joanna, Lemmy for 4, Anushka 5.
Yes, sir.
Okay, 2 minutes, students. Let others join. I will start.
Good afternoon, sir.
Yeah, good afternoon, Mariam. 2, 3, 4, 5. Can you see the screen, Mariam? 1, 7. Were you present yesterday? Not yesterday, day before yesterday. When? Thursday and Friday?
Yes,
Okay,
yes, sir.
fine. Okay, Joanna, Naomi, Lemuel, do you know a parallel line concept? Corresponding parallel line, corresponding angle.
Yes, sir.
Fine, we'll start, students. See, angle and cyclic property will have around 10 properties. 10 properties or theorem. So, I'll explain the basic important ones. Few will keep it pending. We'll see what your teachers did. Whether they cancel it, according to that, I'll conduct. Okay, first, in a circle, let us take any line, arc. Let us take any arc like this. This is first property. See, angle and cyclic property, you can call first property or theorem 1, first theorem. So, theorem 1 is nothing but in a circle, this green line is the arc, and O is the center. The arc subtended by this center, okay, O, I'll name this as A, and I'll draw another chord like this. look like this. Two angles are formed here. Can you tell me AOB? What is AOB, students? AB is arc plus what is OA and OB? What are OA and OB? Radius. Arc,
Yes.
arc plus radius will give what? Segment or sector? R is given, right? Segment or sector? Arc plus radius will give sector. So AOB is one angle. AOB. Next, we'll take the same arc AB plus what is AC and CB? What do you call the line AC, which touches from one circumference to the other, from one point to the other point? Diameter or chord? What do you call? We call it as chord. Arc plus chord. What is arc plus chord? Sector or segment? Segment. So look here. Look here, students. Sector, segment, both are different, but the arc is common to both. The arc is common to both. So the first theorem is the arc subtended by the central angle will be 2 times the arc subtended by the segment. That is, AOB will be 2 times angle ACB. AOB value will be twice. If AOB is 100, ACB will be 50. This is the first property. Okay, AOB will be twice the angle subtended at the circumference, center and circumference. So instead of all this explanation, just remember, with a common arc, AB is a common arc, the angle subtended at the center. What is the value of AOB I am given? What's the value of AOB? How many degrees? 100 degree. If AOB is 100 degree, what will be the value of ACB? ACB should be 50 degree, half of it. So the formula is AOB is equals to 2 times ACB. That is, angle subtended at the center will be equal to 2 times angle subtended at the circumference. Okay, any point on the circumference. The arc should be same. The angle formed in the center will be 2 times any angle formed on the circumference. This is the first property. So through property and the theory part you won't explain. I mean you won't understand. Through angles it is easy. Subtended. Okay, let me take circle. This is an arc. Center. Okay. And from the same arc, I'll draw another chord, student. I'll draw a chord. Another point which touches like this. Okay, there are 2 pairs of lines. 2 pairs. One is in the center, the other one is on the circumference. Fine. Are they on the same arc or different arc? Are the angles subtended by the same arc or different arc? Second diagram. Same arc. Okay, so the formula for this would be, what's the angle subtended at the center? How do you name that angle? In the center, AOB will be equal to, what's the formula? 2 times, twice of angle ACB. So if AOB, for example, this is the formula, make a note of this formula. For example, I'll give ACB is 30 degrees. If I say ACB is 30, what is the value of AOB? What's the value of AOB? 2 into 30, the answer is 60 degrees. AOB is 60. The angle subtended by an arc of a circle at the center is double is twice the angle subtended by a chord. And it should be on the circumference. Look here, it should be on the circumference. Now let me take another arc like this. If I draw a center here, O, and it's not touching the circumference, students. If it is incomplete like this, if it is incomplete, this is not twice. The theorem doesn't follow for this circle. Okay, the theorem is incorrect. The reason is the chords are not touching the circle. It should touch the circumference. Look at this chord. It's not touching it. Center is fine. Center is fine, but the chord is not touching. So you can't apply this theorem on this circle. Okay, you can't apply this theorem. This is the first theorem. Make a note of this. Just draw the diagram like this. Theory part, I'll mark it in textbook. You can just go through that. Look, student, this is the angle subtended. In an arc, the value, this is the angle subtended. So from the same arc, wherever the two arcs end, I'll draw another chord like this. Another chord. A, O, B, and X. So AOB, if AOB is 80 degrees, tell me the value of AXB. What's the formula? AOB is equals to twice of the angle formed on AXB, right? So what's the answer? AOB value, what have I given? AOB is 80 degree is equals to 2 times AXB. So 80 divided by 2, 40 degrees. See, the diagram can be like this. Okay, now tell me what is the value of a full circle, students? Circle, what's the value of full circle? Entire circle is 360 degree. Okay, now if look here, this entire thing is 360. If one part is 80 degree, then what about the other one? The other angle, this angle formed 360 minus 80. Okay, 360 degree minus 80. You should remember even this. The top one, this pink one, entire circle is 180. Look, this is a complete circle. This is first half, this is second half. So 80 degree, 360 minus 80, even that question they might ask you. Okay, the last question is like this. Naomi, Joanna, is it clear? Mariana, not Mariana. Mariam,
Yes. Yes, sir.
Lemula. Okay, next student. Same question, same theorem. I'll give you. Yeah, I'll explain different types of questions, possible questions. If you're getting confused like this, just remember center. The angle formed at center will be twice the angle formed at the circumference. Okay, now one more question. Same circle, it should touch from arc. I'll draw an arc here. Center. They have to mention the center here. Center is this. And on the same arc, it touches like this. First, tell me what is the angle formed in the center. All of you tell me the angle, name the angle which is formed in the center, students. Name the angle.
POR.
Angle POR is formed in the center. POR. Is it on the same arc? Both the angles are formed on the same arc. Angle subtended is equals to 2 times is equals to twice of what is the angle formed on the circumference? Lemula, what did you answer?
PQR.
Yeah, PQR. You should name this entire thing, student. It's not like O angle R. When we talk about arc, you should write this entire thing. POR is equals to PQR. Next, AOB. What concept you have? Now look here. What I'll do is I'll give the outer value. Outer value is this 250 degrees. Outer value is 250. I want you to find the value of angle PQR. Okay, in order to find angle PQR, what is required? If you want to find PQR, which angle is required? PR is required?
POR.
Yeah, but PR is PR given. The interior one is given or exterior? In POR. Exterior is given. Look here, complete circle. This is a complete circle. So what is the value, students? How will you find angle POR? Very good. Angle POR is equals to 360 minus 250. Interior plus exterior. Look here. This is a complete circle. A and B. You can call the top part as exterior, interior, anything. Okay, first half or second half, anything. Both should be 180, 180, 360. So the answer is correct. 360 minus 250. Calculate the value of PQR.
190.
PQR. Who answered? Lemula PQR, not POR. Okay, what you got for POR? POR is equals to 360 minus 250 is not 190. How much is it? 110? Yes, substitute POR 110 degrees. 110 is equals to 2 times PQR. What is PQR then? 110 divided by 2? 55 degrees. 110, 55. Is it clear? All of you understood the first theorem? Shall we move on to the next one? Second theorem. Okay, first theorem was center and circumference. Remember like this, students. Theorem 1 was related to center and circumference. Okay, theorem 2. Theorem 2, circumference plus circumference and circumference. Okay, let me take an arc like this and I'll draw segment. What do you mean by segment? What forms a segment, students? Last class I explained. What forms a segment? Arc plus chord, right? Remember this, arc plus chord. Look, let me draw a chord like this, which touches the circumference. Theorem 2 is circumference and circumference given. So I'll name it as P, Q, R. And on the same arc, I'll draw another chord like this, segment. You can remember circumference or segment and segment, two segment. These two angles will be equal. Angle PQR is equals to angle POR. Make a note of this. PQR is equals to POR. If PQR is 50 degrees, POR also will be 50 degrees. PQR, POR, 50 degrees. So you can remember this as circumference to both the angles formed on circumference or two segments. I've explained the entire concept. Even in the first one, you can remember this as chord, not chord, sector and segment. What is the angle formed in the center, students? Along with radius. What do you call along with radius? If it is radius, do we call sector or segment? Sector. On circumference, chord is used. If it is chord, we call segment. They can ask for MCQ. They can ask sector, segment question, center and circumference. I've explained radius and chord. They can ask you in any way. You should know all these concepts. Next, circumference. When we talk about circumference, which line forms on circumference, students? Which line forms? A chord forms or a radius forms angle on circumference? On circumference, does the chord form an angle or radius? What have we drawn here? Chord. So chord and chord plus chord theorem. This is chord and chord. The values will be same. Okay, so always a chord will touch the circumference, not a radius. Chord will form an angle. Chord and chord, or you can call this as segment and segment. Both as two segments are formed here. Okay, write it however you want. In the textbook, I'll tell you. I'll later mark what to learn. Theorem 2 is also done. So therefore, the angle formed on the same segment, student. Both of these are segments. We call segment. Angle formed on the same segment. That is, the arc should be same. Then their angles are equal. Okay. I'll explain what doesn't form a segment. Look here. Let me draw an arc here. This is one segment. I'll take another arc here, like this. I'll draw another segment like this. Can you all tell me both the segment? What are the names of both the segment? Angle MLN and angle. Where's the angle for? Not PQ, RPQ, right? Okay. Will they be equal? Are they formed on the same arc or different arc? Different arc. So they won't be equal. They are unequal. The values are not equal. This is the concept. If it's on the same arc, their values will be equal. If it's on different arc, they are unequal. So you should know to figure out the chord, students. Chord and sector or segment. See, sometimes chord can be even given like the L, M, and N. Sometimes the chord will be like this, very small, like this. But their angle will be same. Look, their angle will be same. MON, angle MON will be equal to angle MLN. They're on the same arc. Arc is MN. The green one is the arc. Okay, I'll give you all one question. I'll include both first theorem and second theorem together. Yeah, Diyashri, I'll share the recording, Diyashri. You can watch the recording and log in tomorrow because I've started the theorem part. Okay, you watch the recording. From tomorrow you can attend. From tomorrow I'll start exercise, solving questions.
Okay, sir.
Okay, you can do.
Yes.
Yes, fine. Next, A, B. This is a arc and a center. Start from arc, students. Start from arc. Tell me how many angles are formed. Start from this point. Tell me the different angles formed. First,
AOB.
AOB. Is it a sector? I'll ask you a question. AOB, is it a sector or segment? AOB. Answer properly, not segment, sector. How is AOB formed, Ivania? Through chord or radius?
Radius.
So if it is radius, R is present, right, in radius. So is it a sector or segment?
Sectors.
Yes, AOB is a sector. Next, tell me the next angle. What are the next two angles formed? AP, APB, right? P, APB. Okay, is it a Sector or a segment? APB is a sector or a segment? Segment. Who's telling sector? APB students. What is AP and AB? Is it a radius or chord? AP is a radius or chord? A- chord. So it is a segment. Next. Tell me the third angle. What's the third angle? AMB. A- yes, AMB is also a segment. So we have one sector, two segment. This is how we have to understand. Okay. One sector, two segment. And what are the theorems we have? Can you all tell me the first theorem? What's the first theorem, student? Segment is equals to what? Two times? Not segment, sorry, sector. The angle formed in the center. Can you tell me the first theorem? What's the first theorem? Angle subtended in the center, angle AOB is equals to what? Two times angle. How many chords do we have? We have two chords, right? APB or AOB is equals to what? AOB is equals to two times. What's the other one? AMB. Both are correct because both the angles are formed, both the segment are formed using the same arc. These are the two formulas. Now find the answer. All of you will find the answer. I want you all to find the answer for AOB and AMB. APB is given. APB is 50 degrees. First find the direct values. Reasons I'll tell you how to write. Okay, there is even another formula. Theorem 2. What is theorem 2, students? Can you tell me theorem 2? Two segments are on the same arc. Will they be equal or unequal if two segments are on the same arc? Equal. So these two are correct. You can write even the second theorem. You can write angle APB is equals to angle AMB. Same arc, two different segment. So you should remember any one. Either remember like chord, radius chord property, or sector segment property, or center circumference. Center circumference, radius chord, sector segment. Okay, you can use the second property. What is angle APB? APB given? APB is equals to 50 degrees. If angle APB is 50, angle APB is equals to which other angle, students? Which one? Angle APB is equals to angle AMB. Yeah, reason I'll tell you how to write. Okay, first complete. Both are 50 degrees. 50 and 50. Okay. If this is 50, what is the angle formed in the center? What will be the angle formed in the center? You can use this formula. AOB is equals to 2 times APB. APB is 50 degrees. What is 2 into 50? 100. AOB is 100 degrees. So look here, theorem, I'll tell you how to write. Reason. Yeah. For this, look, we have written a statement saying that APB is equals to AMB. Both are equal. What are these students? APB and AMB. Are they sector or segment? Look at APB and AMB, sector or segment?
Segment.
Segment. Both are segment. So you have to write. Let me check. So you have to write angle. Angle is formed. Angle in the same segment. Okay, angle in the same segment are equal. Angle in the same segment of a circle are equal. Both are inside the circle. So angle formed in the same segment. Both are segment. Angle formed in the same segment of a circle are equal. This is the reason you have to write. Angle in the same segment of a circle are equal. All of you will make a note of this. Is students done? Did you understand this concept? Any doubts?
Yes.
Will have any doubts? No. Okay. Now third property. Third property is semicircle. Angle formed on semicircle. Okay. Before that, see here. If you draw a circle like this, one arc. Tell me the value of BAC, students. If BOC is 50 degree, what will be the value of BAC? Or let me take 80 degrees. 80. If BAC is 80 degree, what will be the value of B? If BOC is 80, what is the value of BAC?
40 degrees.
40 degrees, right? 40. Now look at the angle. Look at the angle. We have BOC is 80. Okay, BOC is 80, and outside the value is different. Interior, exterior, which means the angles which you are going to find, are not continuous. That is, look here. If I mean, look, 40 degree is given. Opposite to 40 degree, there is one more angle, student. Opposite to 40 degree, there is one more angle. We are not going to find that. Okay, we're not going to find that. We are finding the other part, the below one. The below one is given 80 degree. Below one is 80. Look, you'll get question like this. Like this. Like this. So here they'll give you 50 degrees, not 150. Let me say 150. Okay, and they've asked us to find angle PAPB. Okay, APB. Now can you tell me the arc? Which one is the arc here? Which one is the arc? I'll draw two, students. Look at like this. One is the yellow one, and the other one is this blue one. Okay, can you tell me the arc? Which one is the arc they have taken? Look at both the angles and tell me which is the arc they have taken. The blue one or the yellow one?
Yellow.
No, if they've taken yellow arc, look at the circle APB. Where is APB formed? APB should have been formed somewhere on top, right? Not only on top. Wait.
Yes.
Yes. APB should have formed somewhere on top. It should be formed above. But here they have taken the blue one, student. They have taken blue one. That's the reason the angle is formed on the circumference APB. So 150 is given. Angle AOB is 150. How do you find angle APB? Can you tell me the value of APB? How will you find the angle APB? Yes, give me the answer. How will you find angle APB?
So should be minus 360 minus 150.
Correct. So in order to find APB, students, in order to find APB, we don't need this 150. You can't make half of it. Look, they are just opposite to each other, right? They're opposite to each other. We don't need opposite angle. We need the other angle, exterior one. Only if you find exterior one, you can find half of that. Half of that will be APB. See, the same concept here. I'll explain here. Where is this angle? Where is angle AOP and AOB? Are they exactly opposite? BAC and BOC. Are they exactly opposite? Or is there any angle in between? Do we have any angle in between?
Yes.
We have angle in between, right? The exterior angle we have in between. In the same way, there should be some angle in between them, students. In between the center angle and the circumference, there should be some angle in between. So therefore, you can't 150 and make it half of it. If you want to find APB, if you need to find APB, first you have to find this exterior angle. So what will be the value of this exterior angle? 360 minus
Minus 150.
360 degrees minus 150. How much is 360 minus 150? 210. 210. See, there is a, yeah, they are not equal, they are not exactly opposite. There is one angle in between. So if AOB is 210, this will be half of it. Half of 210 is 105 degrees. So don't get confused. If they give 150, don't write APB as 75. 75 is wrong. First you have to find the exterior one, then from there. Yeah, look at the first diagram. Opposite to angle BAC, there is one angle. But we are not taking with reference to that. We are taking with reference to the outer one, outer angle. 80 and 40. Even in same way here, we take the value for the outer one. Okay, so this also comes under part 1. Theorem 1. It comes under theorem 1. Okay, next angle formed on semicircle. Next part is angle formed on semicircle. See, this is a circle, center. I'll draw a line like this. So this line AB splits AB. This line AB splits the circle into two half, students, two parts. First half, second half. First, second. Okay. We call it as a diameter. AB is a diameter, and diameter will split the circle into two halves. Now, semicircle. First semicircle and second semicircle. First semicircle, second semicircle. Okay, now if an angle is formed like this, let me draw a triangle here, like this. So any angle formed on the semicircle will be 90 degrees. This angle will be 90 degree. This angle will be 90 degree. The reason is same like theorem 1. What is angle AOB, students? Is AOB a straight line? Isn't it AOB a straight line? So what is the angle formed here? If it is straight line, protractor, what is that? 180 degree. So in center, what is the angle formed? AOB is in center, right? What's the angle formed? 180 degree. If it is in center 180 degree, in circumference, isn't it half? Isn't it half? AOB is Yusra. Yeah, who had called? Any doubts?
Not so.
Okay, I heard somebody. Fine. See, the same like theorem 1, but semicircle. Okay, this is theorem 3. Theorem 3 says any angle formed on the semicircle is 90 degrees. This is the reason. 180 degree, 90. And here the arc is this one. They have taken this arc, the green one. From this arc, angle is being subtended like this, 180. Okay, this is theorem 3. The angle of a semicircle is a right angle. The angle formed in a semicircle is a right angle, like this, or you can form an angle can be formed like this, even this, like this. Tell me the value of ACB, students. What's the value of ACB? ACB is equals to, what will be the value of ACB? ACB also will be equal to 90 degrees. Okay, any circumference which is drawn as a semicircle, look at ACB. Let me take another angle, P. What's the value of APB? 90 degrees. AB is the diameter. From diameter, you draw any, yeah, you can remember like this. From diameter, you draw any chord. From diameter, you draw any chord that will be 90 degrees. This, even this, 90 degrees. AMB also will be 90 degrees. Okay, now let me take APB. What is APB, students? What's the angle formed on APB? What did I tell you all? 90 degree. So this is a circle. Semicircle, 90 degree. Okay, can you tell me the semicircle? Where is the semicircle found? How do you name the semicircle, students? What are the points which is touching the semicircle? A, O, B, and P. A, O, B, P is the semicircle. A, O, B, P. Or you can name it as B, O, A, P. Even that is fine. Or P, B, O, A. All the points which is touching the circumference, semicircle, we call it a semicircle. So this is third theorem. The converse is nothing but the opposite. Third theorem is, in a semicircle, if you draw a triangle, we get 90 degree in a semicircle. The converse of that, the meaning of converse is opposite. That is the fourth theorem, theorem 4. Theorem 4 is the converse. That is nothing but, you take a right angle, and let us touch a circle like this. What will this circle be, students? What will be the value of this circle? This circle will be a semicircle. This is the converse of it. You take any right angle triangle, and you draw a you draw a line like this, arc, not a line, arc. That will be a semicircle. Look, this is an arc. In a right angle, I have drawn an arc here. That becomes the semicircle. A, P, X. I'll name this as APX. Okay, in the first triangle, in theorem 3, there is a triangle, right? Here, APB. In APB, what is AB, students? What do you call AB as? What do we call AB? According to circle, what's the line AB? According to circle, what do you call the line AB? AB, you call it as diameter. Okay. According to triangle, what do you call AB? Opposite to 90 degree. Hypotenuse. Very good. See, same concept, but the lines, the same line. It varies according to the concept. Okay. In the second diagram, tell me what is the diameter. In the second diagram, what is the diameter? Look, if you want, I'll complete this circle. Look here, I'll complete the circle like this. Let me complete the circle. Semicircle, green plus pink, both together form a circle. Okay, now tell me what is AX with respect to circle. What is AX with respect to circle? Diameter. What is Lemula doing? Lemula, Naomi, Joanna, did you all understand all this? Mariam. Okay, Naomi, now tell me in angle APX, according to triangle, what is AX? According to triangle APX. Very good, hypotenuse. So these are the concepts you have to remember. Theorem 4 and theorem 3 and theorem 4. They both are opposite to each other. Okay, that's it. Look here. Once again, I'll just explain that. See, we take a circle and there center is given, student. Center. From center you draw. What do you call this line as? All of you will tell me what do you call this line? Diameter. Okay, from diameter, if I draw angle like this, what's the angle formed here? 90 degree. Yes, this is theorem 3. From a diameter, you draw a chord. From diameter, you draw a chord, it forms 90 degree. If this is 90 degree, what will be the outer value, students? Straight line. What is this? 180, right? Both are 180 and 180. Okay. From triangle PQR, from triangle PQR point of view, angle R is 90 degree from triangle PQR. Then what do you call angle side PQ as? What do we call side PQ? Side PQ is hypotenuse. Remember all this. You have to use your trigonometry here. Okay. There are a few questions to use trigonometry. Hypotenuse. 90 degree hypotenuse. Next, what else? Hypotenuse. Next. When circle is given, this is third theorem. Fourth theorem is just opposite. You take any right angle triangle. Let me take a right angle triangle like this. ABC. ABC is a right angle triangle. And an arc. Draw an arc which touches ABC. What do you call this circle as? What do you call this circle? It is a semicircle. Okay, this becomes a semicircle. Yes, this becomes a semicircle. Opposite to that. So inside a circle, when right angle is given, third theorem. In a right angle, we draw a circle, that is fourth theorem, converse of third one. Okay, open page number 280, all of you are 280. This chapter, can you all see the first 4 theorems you have completed? You can just ignore all that. Page number 280. Can you see theorem 1 given? Theorem 1. Angle subtended by R. Yeah, just go through theorem 1, students. Just the whatever part they have given. Look, given to prove. Given to prove. Just ignore all this. I want you to go through what is given there. Theorem 1. Just go through theorem 1 and the diagram. Theorem 1 and diagram. Same. Page number 281. Can you see the second theorem? Angle in the same segment of a circle are equal. Second theorem. Yeah, don't go through all this proof, construction, forget all those things. I just need you all to go through theorem. The first 2 lines and the diagram. That's it. So whatever I have explained the entire concept. Go through that. Even page number 282. Yeah, page number 2 is, yeah, Yusra, do you have textbook with you?
Yes, sir.
Open page 280, Yusra. Page 280. Okay, let me share a pic, students. I'll tell you how to go through the theorem. Oh, another 5 minutes, we'll end the class. Hmm. Look here, first theorem, we studied the first theorem. So just go through this one, students. Theorem 1. Ignore all this. Okay, I have explained all this concept. Explanation, statement, reason is not required. See, ignore all this. Just the diagram. Yeah, go through theorem 1, diagram. Ignore this pink, this purple thing, all these things. Ignore it. Did you all understand what I told? All of you understood?
Yes, sir.
Okay, just the theorem 1, those two lines and the diagram. Same goes for this. Look here. Theorem 2. Just go through theorem 2 and these two diagrams. Just ignore all this. Same thing. Open page number 282, students. All of open page 282. Can you see theorem 3? Angle in a semicircle is a right angle. Page number 282. Yeah, go through that. Just theorem 3 diagram. Theorem 4, converse. If an arc, mostly you won't understand this converse. Just remember what I told. Converse of theorem 3. So you take any right angle, you draw a circumference, that will be semicircle. Okay, page number 283, that is left. Cyclic quadrilateral. Only one concept is left. Theorem 5. Yeah, theorem 5 and theorem 6 will complete it tomorrow. And tomorrow, I want all of you to attend. We'll be solving questions. Two theorems are pending. I'll explain the theorem. And page 297. There are a lot of questions, students. So I'll try to attend regularly. I'll complete all the questions. Fine. Tomorrow log in at 12 o'clock. Today it got late. All of you log in at 12 o'clock tomorrow. Okay, that's it for today. You all can leave. Log in at 12 tomorrow.
No,
Yeah, bye students. You all can leave.
after that, yes.